This is the beginning of chapter 11, probability. Now, before we can learn to calculate probabilities of a specific outcome, we first have to figure out ways to count all the different possible ways something can happen. So for example, if we want to know the probability of drawing a 4 from a standard deck of playing cards, we must first determine the number of ways of drawing any card from a deck of playing cards. So the first 3 sections in this chapter, we are just going to be discussing different ways of calculating the total number of ways something can happen. Now, one way of doing that would be to create a tree diagram. So for example, let's say you have a job interview tomorrow and you need to decide what you will wear. You have 2 pair of appropriate pants. One pair is black and the other is gray. You have 3 nice shirts in red, blue, and green. How many different interview outfits can you create? Well, so what you can do is do something like this. So you start out with the outfit. You have 2 choices for your pants. You can wear black. You can wear gray. Okay. And then from there, you have 3 tops that you can choose from. You can have red, you can have blue, and you can have green. And with gray pants, you can also have red, blue, and green. So how many different ways can you do it overall? 1, 2, 3, 4, 5, 6. You have 6 different outfits you can choose from. Okay. Now, it's always possible to create a tree diagram in theory, but I think you can see that these things can grow really complicated really quickly. Right here, we only had 2 choices and 3. If those get any larger, or you have more groups of things to combine, theoretically, you can do a tree diagram, but chances are you're going to mess it up because you're going to get lost in it. Okay? So instead, we have what we call the fundamental counting principle. If you can choose one item from a group of M items and a second item from a group of N items, the total number of 2 choice items is M times N. So if you apply this to the problem we just talked about, we had 2 choices for pants. We had 3 choices for shirts. So we had 6 choices overall. It's really kind of easy there. Okay. So let's just work a few more problems using this formula. The model of the car you are thinking of buying is available in 9 different colors, 3 different styles: hatchback, sedan, or station wagon. And how many different ways can you order the car? Okay, so we need to pick one of the 9 different colors, and then one of the 3 different styles. So there are 27 different ways to buy that car. Okay. Now for a temporary job between semesters, you are painting the parking spaces for a new shopping mall with a letter of the alphabet and a single digit from 1 to 9. The first parking space is A1 and the last parking space is Z9. How many parking spaces can you paint with distinct labels? Okay, so we have 2 things to fill. We have the letter and then we have the number to fill. How many different ways can I choose a letter? There are 26 letters in the alphabet. So choose a letter and then I choose a number and it says from 1 to 9. So there are 9 ways to do that. So I need to do 26 times 9, which gives me 234 different spots. One thing I do want to point out is to be careful when you have numbers like this. This says 1 to 9. Occasionally it might say 0 to 9. And if you're not paying attention to that and you consider that as 9 things to choose from instead of 10, it's just a very easy mistake to make. So be aware of that. Okay. Now, here and the one before, we've only had 2 categories that we were dealing with. But we're often going to have a lot more than 2 categories. The principle can be generalized even further, and basically you just keep multiplying. So if you had 9 choices for the first category, 2 choices for the second, 3 categories for the third, you would just multiply 9 times 2 times 3, and you just keep going on and on and on. Okay, so a couple more example problems. Let's say a car model comes in 9 colors, with or without air conditioning, with or without a sunroof, with or without automatic transmission, and with or without anti-lock brakes. In how many ways can the car be ordered with regard to these options? Okay, so first let's choose a color. I have 9 options there. I need to decide whether or not I want air conditioning, and there are 2 choices there. With or without a sunroof, there are 2 choices there. With or without automatic transmission, 2 choices there. With or without anti-lock brakes, another 2 choices. So to find out the number of ways that the car can be ordered, I multiply 9 times 2 times 2 times 2 times 2, and that gives you 144. So there are 144 different car options here. Okay. You're taking a multiple choice test that has 8 questions. Each of the questions has 3 answer choices with 1 correct answer per question. If you select one of these 3 choices for each question and leave nothing blank, and how many different ways can you answer the questions? Okay, now this has a little thing in here that may mess you up. You're not going to multiply 8 times 3 because you're not choosing one of the 8 questions to work. You have to answer them all. For question 1, you have 3 ways of answering. Question 2, you have 3 ways of answering. 3, you have 3 ways. 4, I don't mean to circle that. You have 3 ways. And then all the way up to the 8th question, you have 3 ways of answering that. So you need to multiply 3 times 3 times 3, so on, 8 times, which is 3 to the 8th power, which is 6,561. There are a common total of 6,561 different ways to answer those questions. And then the last one. How many different 4-letter radio station call letters can be formed if the first letter must be a W or a K? Okay, so we have 4 letters to fill in. The first must be a W or K, so I have 2 choices there. Now, for the rest of these, it can be any letter. So, and we are allowed to repeat them. So I have 26 options here, 26 here, 26 here. Multiply those straight across, and you get 35,152 different call station combinations.